In this tutorial, I'm going to explain you how we can do moderated mediation in SPSS. This tutorial includes two sessions. The first session, I'm going to explain you the conditions or establish a moderated mediation. The second, I'm going to use a real-world data to show you how you can do that in SPSS. Now, let's go to the first session. Basically, there are three conditions to establish a moderated mediation. And as you can see that here as a name called model 8. These model numbers basically are from Andrew Hayes. He published quite a lot of publications about mediation analysis. Since that, his publications are very influential in this field, in the behavioral research field. So a lot of other researchers will just use the same model number as defined by him. Let's look at the first condition. It's called C pass. So C pass basically is here, is this pass. Is this pass. And C pass, we can write a regression model. So the first is Y, namely here, and the X, and then the moderator W, and then the interaction. The key point here is that we would like to make sure that the B3 is significant. You might have a question whether B1 and B2 need to be significant. The answer is no, they do not really matter because we're talking about model mediation, and for the model A, it needs that the interaction item need to be significant. But the B1 and B2, it doesn't really matter. Another one is A pass. So we know that C pass is here. A pass is here. For A pass, we can also write a regression model. The difference is that different from the C pass dependent variable is Y, but for A pass, the dependent variable is a mediator M. And there's an X W, and then the interaction between X and W. The key point here, we would like to make sure that the B3 is significant. You might again have a question that what about B1 and B2? It doesn't matter because here we are going to focus on the interaction. Lastly, we're going to make sure that the B pass is significant. How we can write the B pass? The regression model is that B pass not only the mediator, but also you need to write the other component. So as you can recognize that this part basically is earlier, the first step we wrote earlier, the C part. So this is the original C. And then we just add a mediation component. We want to make sure that the B4, namely the regression coefficient for the mediator, needs to be significant. You again might have question B1, B2, and B3. It doesn't really matter. The only thing I would like make a comment is that the B3 here, in this step, the absolute value should be smaller than the B3 in the first step. So the B3 in here, the B3 here, in the C part without any mediator. So the B3 here, so should be, so the thing I would like to say is that the B3 here, this B3, the absolute value should be smaller than the B3 without this mediator. So that's you expect this. But the key point here is that the B4 need to be significant. Okay, now we know these three conditions. Okay, now I'm going to use a real-world data example to show you how we can do that in SPSS. So this is the data example, and based on this paper, I'm not going to explain the theoretical part of this paper or this model because that's not the focus of this tutorial. And the author of this paper published, or they post the data file And so I download that data file they post on internet, and then I'm going to use that data file to explain to illustrate how you can do that in SPSS. And if you are interested in the theoretical part, I'm going to put the link to this paper down below in this video, and you can go to find that paper to read by yourself. But here we're going to just focus on the data analysis part. So in their model, there's X, yes, and this is the moderator, and this is the mediator, and this is the Y, dependent manager. Remember that this is the theoretical name, the name in that model, but in that data file, they have the variable name, which are not the same as the model name. So you need to, when you download the data by yourself, you need to be aware that, okay, the data, the variable name in the data file are not directly, they are not the same as in the theoretical model, the variable name. But this is not that important. But you just need to be aware of that. Okay, so I write out again here. Next, I'm going to show you how we can do that in SPSS. So the first step is that we're going to do some regression for all the three conditions I just discussed. Actually, and we are going to use the process, this module in the written by Hayes. And we're going to use that model 1 to do all these three analysis. Of course, you can use other linear regression function in SPSS to do that, but we can just use the model 1 because model 1 basically is the moderation, and you can add some variable as covariate in model 1, and then again, I'm going to use the process using a specified model 8 to do the analysis. The main function, we just want to calculate the confidence interval, use the process. Okay, now let's switch to SPS. So this is the data file. As you can see that this is X as mentioned, this is Y, this is mediator, this is the moderator, and this is the manipulation track, I believe. So we do not need to focus on the last column, we only need to focus on the first 4 columns. So as mentioned, we're going to use the model 1 to do some analysis. So we're going to use the regression and use the Hayes process. I assume you already had a process installed in your SPSS. So we just need to put the condition as X. Remember that we're going to run the first condition, yes, which is the X, the W, this is the moderator. We're going to use the model 1. And we're going to keep the 5000 here, so we can just hit the run. So here we're going to expect that the interaction should be significant. So this is the interaction. As you can see, the p-value is 0.02 and regression coefficient is 0.35. So we're going to compare this regression coefficient with later, compare with the model, add the mediator. We're going to expect that that regression coefficient should be smaller. Okay, so here we it meets the first requirement, which is that about interaction should be significant, the A pass. Sorry, this is a C part actually. This is the C part. Okay, now we're going to do the second regression. Remember that the second regression, the dependent, namely the regression on the A pass. Here, the dependent manager is the mediator. Yes. So this is the A pass, and we're going to expect that the interaction is significant as well. So as you can see that the interaction, so remember that this now dependent manager GSR, this is the mediator. Earlier, the first regression we did, the dependent manager is price tag. Yes, but here the determinant measure is GSR, the mediator. So here the interaction item, the p-value is significant as well. Okay, now we're going to do the last, the B part. Yes. So the dependent measure is price tag, the Y, and the X W. Okay, now how we're going to deal with the mediator? So basically, we can actually directly run this as model A, because model A equal generate. So let's just run model A. So this is the mediator, yes. And we do not need to focus, we do not need to pay attention to this. So this is the Y, X mediator, moderator, W. And we're going to run the model 8. Model A has two major, it generate two regression. One is the A path. So the A path is the coefficient 0.07. Yes, the same as we run earlier, use model 1. So 0.0717, 0.0717, exactly the same. So the A path, yes. The model A, this regression also generate a B path, which is what we want. It's not what we want, but it's the main focus. Yes, it's the last step, the last requirement to establish the model mediation for model 8. So here we're going to, as mentioned, we're going to focus on the regression coefficient for the mediator, namely the GSR. As you can see that the p-value here is 0.02. So it means that the regression coefficient for the mediator is significant. So it meets our requirement. In addition, as I mentioned, the comment I made earlier was that the regression coefficient for the interaction item, after adding the mediator, the regression coefficient absolute value should be smaller than compared to model without the mediator. Yes, so this is 0.30. And earlier, as I mentioned, the first regression we did where the interaction regression coefficient is 0.35. So that is basically is consistent our expectation. Yes, so expect this regression coefficient absolute value to be greater than the other one. I think that's it for this. Another thing is that, as I mentioned, that we're going to expect the Mori mediation. That this is the confidence interval, yes, and there's an index. You might be wondering, okay, what this index mean? This index basically is that index actually is the regression coefficient in the A part, the interaction item. So namely the B3 here, the regression coefficient for the interaction item in the A part, the B3, and then also times the regression coefficient of the B4 in the B part. So we can double check about that. So let's go back to the SPSS. So this is the regression coefficient here, yes. So this is the A part, yes. The A part, the dependent variable is the mediator. So the interaction item for the A part is minus 0.0717. So this is the regression coefficient for the interaction item in the A path. And then we're going to find the regression coefficient in the B path for the mediator, which is the negative times the negative number so you cannot type the negative because it will become negative. But so it's like 0.7499. Okay, I did not type the negative here, but you will remember this is negative. And then we turn together. So this is bit positive, yes, but I did not type the negative, but this is bit positive. So as you can see that, so 0.0537 is 3A, roll it up. So as you can see that this is where it came from, is the production of is the product of the interaction item at the A part and the regression coefficient for the mediator in the B path. And this provides a confidence interval for this index. So this confidence interval, both of them are positive. Lower bound and upper bound, the confidence interval, both of them are positive, which means that it doesn't include a zero in the middle. It means that the moderate mediation model works. So I think that's it. Another thing I would like to briefly mention is that there are other types of moderate mediation. Earlier we discussed that the model A, yes, which the A part and C part both have moderation. The interaction items are significant. But sometimes maybe the A part, the A, B, C, the A part is not significant. Only the C part is significant. In this case, it's model 5. In contrast, it could be A part only significant, but C part is not significant. In this case, it's model 7. All these model numbers are based on Andrew Hayes' book. So you want to learn more about mediation, moderate mediation, you can go to find this book to study more. On the other hand, on the other side, sometimes it could be like the B part is significant, but the A and C, the interaction effect, are not significant. In this case, you are going to use model 14. Sometimes the A part interaction effect is not significant, but the B and C are significant. In this case, you are going to use model 15. There are other types of model as well. You're going to find this book, and this book provides a lot of different model types. So that means that there are other types of moderate mediation. So I would recommend that you would like to learn more about moderate mediation, definitely you're going to check out this book. So I think that's it. Thank you for watching, and if you have any questions, feel free to comment down below, and I'll do my best to answer the questions you might have. Okay, thank you for watching.